Hi everybody, welcome to this session about Azure Arc enabled PostgreSQL Hyperscale. First, I would like to thank you. Thank you for your time and thank you for choosing to spend this next hour with us. I know that this year of 2020 is very difficult for a few of us, so I really appreciate that you decided to spend the time with us today. Before we get started, let's do a show of hands. Who from you guys have heard about Azure Database for Postgres Hyperscale enabled by Azure Arc? Let's do a show of hands. Yes, I know we are remote, but we still can do that. So if you heard about it already, or if you know some about it, please raise your hand. See, I see a few heads nod. Yes, no, maybe. So doesn't matter if you heard some and maybe not so much. I'll tell you everything that you need to know about it, right? And today we're going to go through a few topics. First, I'd like to give you a high-level definition of it so that we set the context. So Azure Arc enabled Postgres Hyperscale is a hybrid database service that runs on any physical infrastructure. It runs a standard PostgreSQL database engine to which it adds the Citus extension. Citus extension is an open source extension to Postgres that brings the hyperscale capability to this engine. By doing this, it brings to Postgres unprecedented level of scales and performances. It achieves this scale and performance level by doing two things. One, it scales out the database engine horizontally. And number two, it distributes the data and your query. Right. So you may ask yourself the question, so where does that fit and how does that work? I'll tell you about it. So first we'll go with looking at why Postgres. You may not be aware so much about Postgres, so I'd like to tell you a few things about it. Then we'll look at what is Azure Database for Postgres Hyperscale Citus before we go look at what is Azure Arc. Once we've done that, we'll look at what is Azure Arc enabled data services before we go to looking at where Azure Arc and Postgres Hyperscale meet. This is where the story really ties together. But you may wonder, yeah, show me the product, that may be better, right? So let's dive in. So why Postgres? There are a few reasons why you may be interested in Postgres. First and foremost, it's one of the most appreciated database engine on the market for different reasons that we'll see later on. But whether you're a DBA, a developer, or a decision maker, there are multiple reasons why PostgreSQL would be a good choice for you. First and foremost, Postgres is open source, and there is a large and vibrant community that builds Postgres. Second is Postgres has been on the market for decades. It means that it is proven to be reliable and proven to really be a good database engine to take care of your data. And it has a very rich feature set that is extensible, meaning that no matter what business you're in, it is likely that the Postgres database engine is a good fit for you. So let's look at different dimensions on why Postgres could be a good fit for you. First, as we mentioned, it's open source, and there is a large and vibrant community. And the Postgres database engine is both relational and able to handle key value pair types of data. It means that no matter if you have a business that really look at tables, or if you need to store unstructured data or this kind of thing, then Postgres is able to do that for you. It has a lot of flexible data types, in particular geospatial. And also Postgres is well known to handle very efficiently JSON-B types of data. Postgres, like any database engine, has a rich indexing capabilities along with full text search capabilities. It is also highly customizable. As you might know or see, there is hundreds of parameters that you can use to tune the behavior of the database engine. So highly customizable. And also it is extensible. So PostgreSQL is a database engine that allows you to expand its functionality with additional modules. and you can either build those modules yourself or get those modules from the community. It means that by being so much extensible, there isn't pretty much any niche in the market or any type of scenario for which you cannot find the right logic to expand the database engine to. Aside from that, from a developer experience, PostgreSQL supports a variety of languages like Python, R, V8, Ruby. Since I mentioned there is a large and vibrant community, the updates that you get about Postgres are quite frequent, right? And so on a regular basis, you can benefit from the latest and greatest of the innovation that gets into Postgres. And last but not least, Postgres can be highly performant. So all that together really shows a few reasons why you may want to consider Postgres for your business. Now that we looked at Postgres as the database engine, let's look at what is Azure Database for Hyperscale Citus. Azure Database for Postgres Hyperscale Citus is first and foremost a managed database service in Azure. It means that you don't have to worry about the infrastructure. You get your subscription, you deploy an instance, you get it, you send your data, you connect your application, you're good. This Postgres engine in Azure runs the Citus extension, which, as I mentioned, is an extension of Postgres that brings the hyperscale capability to Postgres. What it does is it converts the single database, single instance Postgres into a cluster of multiple instances, which grouped logically form a cluster of multiple instances that we are using to scale out the Postgres database engine. So by doing that, we really scale out the compute horizontally, meaning that we not only expand the number of cores, but because those cores are hosted on different physical machines, right? Well, you really benefit from a scale out capability that really brings superior level of performances and scale. Because as we do that, then we distribute the data and the query so that at all times you can benefit from the most efficient execution plan and all the power of your cluster distributed across multiple servers. So how does that work? Let's put things in perspective and look at it from a concept level. Within a Citus clusters, we have several instances of Postgres. Those instances of Postgres play different roles into the cluster. We have two roles. We have the coordinator role and the worker role. The coordinator role here is a dedicated instance of Postgres that is the interface between the client applications and the worker nodes that really process the data. We have a set of worker nodes, which are instances that form the cluster to which we're going to distribute the data and distribute the query. So when you have an application that connects to the Postgres Hyperscale Citus, then it connects to the coordinator node, and the coordinator node fans out either the data or the query to the different workers. What happens is the data resides on the workers. The coordinator do not have any data except metadata that are a representation of where your business data is located within the cluster. So let's take a few examples. On this example, we are creating a table. So the create table statement hits a coordinator. The coordinator distributes the create table statements to the worker nodes. And as you send data, the data is split across the nodes evenly through a distribution column. Each piece of data that we see on each instance here, for instance, or there, right? Each of these is a Postgres table that you don't have to handle. The logic of the product takes care of it. It means that we shard your data into multiple chunks and we distribute that on the different workers. Now let's look at how Postgres distributes queries across the clusters. Let's say you have a query that does an average on some data, right? So the query hits the coordinator. The coordinator sends the subqueries, I would say, to each worker. The workers process the data, sends the result set back to the coordinator, and the coordinator in turn marshals the result set back to the application. By doing this, you really maximize the power across the different servers in your cluster, and you can reach very, very significant levels of performances, as I'll give you examples later. Let's look at another example here, a transaction that is distributed. Here, for instance, we're doing an update on a particular set of rows. And because the coordinator knows where the data is stored, the coordinator is going to send a query only to the node that it knows has data it needs to process. By doing this, we are ensuring that the workload is sent to only the node that is expected to do some work, meaning that other nodes can still have maximum power to satisfy other queries that may be running. So there is no resource contention, or much less than in a traditional system. If we took another example here where I have two update statements, then the same thing, the coordinator is able to fan out those different parts of the transaction to the respective nodes so that the data is processed on the nodes and returned back to the coordinator and back to the application. So you may wonder, how far can Citus scale? Well, I'll share a few numbers here to you. Look at those numbers. 5, 10 billion rows, 700 billion events, 2.6, almost 3 billion rows here, 1.6 petabyte of data, 2.4 terabytes of memory, almost 1,300 cores. And if you look at it, even Microsoft is using it. We do have the Windows team that is using Citus extension in Postgres to process signals from more than 800 million Windows devices. And with that amount of data, which is about 2 petabytes here, most of the query do run in less than 0.2 seconds. That is something that is very, very performant. And I'll let you look at the details of that study when you have some time. Another example here, ASB, one of our customers, has been able to improve their query from 40 minutes to less than 2 minutes on a huge amount of data for a multi-tenant application that has a millisecond latency requirement. So we have multiple examples by which Postgres Hyperscale is very, very performant. Right? So with that said, let's look at Azure Arc now. So we looked at PostgreSQL, the database engine, plain and simple. We looked at Azure Database for Postgres Hyperscale Citus, which is the hyperscale form of Postgres in Azure that runs the open source Citus extension that distributes the data across multiple nodes to provide unprecedented levels of scale and performances. Now let's look at Azure Arc, and then later in this presentation we'll see where this idea of Postgres Hyperscale and Azure Arc merge together to form the story that we are telling you about today. So what is Azure Arc? Let's put things into perspective. Hybrid today is a norm. Most of the customers are considering to use a form of hybrid technology in the future, or are already using a form of hybrid technology today. It can be cloud providers, it can be other types of technology, but bottom line is customers want to be able to run their workloads independently of the infrastructure that workload runs on. From that point of view, Arc is helping customers to manage the complexity our customers are facing. So what kind of complexity are we talking about here? There are different aspects of complexity that our customers tell us about. One is about the complexity around the number of applications. Tens or thousands of applications. Some of them are serverless, some of them use databases, some not. You have a variety of dev suites, so it can be very complicated to manage all those applications at scale. The other element of the complexity that our customers are telling us they are facing relates to diverse infrastructure. You may have infrastructure on your premises, on the premises of some hosters to whom you delegate some of your workloads. You may be using cloud services, which constitute another element of this complexity. If you are using multiple cloud providers, how do you have a seamless experience across those cloud providers that would simplify the experience you get to manage those workloads and grow your business, right? So we know that there is some complexity around that, and it's not always an easy task. Well, Azure Arc is here to help you manage the situation. With Azure Arc, you can get elastic scalability. You can get self-service provisioning. You can get built-in monitoring and security. You pay like a cloud model for just what you are using. You can benefit from management at scale from anywhere on any physical infrastructure, be it at the edge, on your premises, in cloud providers. And you can benefit from automation at scale, and we'll tell you about that in a moment. So to help on those challenges, Azure is helping our customers with Azure Hybrid. So let's look at what Azure Hybrid provides here, and let's see where Azure Arc fits into that picture. Azure Hybrid is this approach of Azure Cloud that enables you to benefit from the innovation in Azure everywhere, no matter where you are, no matter where your workloads are. And there are three pillars to Azure Hybrid. One is Azure Stack. Number two is Azure Arc. And three is Azure IoT. So Azure Stack is the form factor of Azure services where Microsoft provides the hardware and the software. So that's very key to realize. Microsoft provides hardware and software for Azure Stack type of services. Azure Arc, Microsoft provides the software, but you as a customer provide the infrastructure. Azure IoT is everything that relates to those sensors and those small devices that feed data to where you need to process and store this data. But the key here is to look at Azure Hybrid in this perspective. Three pillars: Azure Stack, Azure Arc, Azure IoT. Let's set aside Azure IoT because it's not the topic for today. Let's set aside Azure Stack. Azure Stack is where Microsoft provides both hardware and software. It differs from Azure Arc, which is our topic today. And Azure Arc is a form of Azure services where you as a customer provide the infrastructure, we as Microsoft provide the software. And together, we enable your workloads on your infrastructure, no matter where it is, at the edge, on your premises, on the premises of hosters, and also on any public cloud. Azure Arc brings those innovation no matter where the infrastructure is. Run data services anywhere. It extends the management capability of Azure to any environment you may be using. It allows you to adopt cloud practices on premises. And also, it allows you to benefit from all the innovation that Microsoft is doing through Azure in terms of security, compliance, governance, and all those things. So really, Azure Arc extends the boundaries of Azure to provide those services to you. So think of it like so far with Azure services, those services run in the Microsoft data centers, right? With Azure Arc, we are expanding the boundaries of Azure to provide those services on infrastructure that typically are not within the boundaries of Azure data centers. Those infrastructure are in your premises or other public clouds. From that standpoint, no matter where you are, again, edge, like edge sites or mobile users or mobile workloads, your data center, public cloud, you're going to have a similar experience no matter where these systems are. We are going to provide you a single pane experience, single glass experience where we are going to abstract you from the physical location of those workloads. So what are those scenarios of Azure Arc that we would like to look at? First, imagine that you have to organize and govern and manage thousands of machines, VMs, physical servers across multiple environments or multiple sites. right? Whether those are Linux or Windows machines, then how do you do that? How do you consistently make sure that you have good governance, make sure that the security is tightened, make sure that you identify whether a configuration did drift out of compliance? It's very complicated. For that, to help you, we have Azure Arc for servers. With Azure Arc for servers, when you enroll an existing server or deploy a new server in an Arc environment, you are going to be able to manage those servers at scale from a single pane of glass experience from the Azure Portal. From there, you can define policies and apply those policies across those servers. You can identify when a server or VM is drifting out of policy and take corrective actions. You do not have to connect to very different sites or environments to figure out if something is off. Now, with Arc, you're going to get that clarity right away. Second scenario where Azure Arc is going to help you is, let's say you have to manage Kubernetes-based application at scale. For instance, you may be a retailer and you may have stores across the globe. How do you ensure that whenever you bootstrap a new store, how do you ensure that that store starts with the right environment from an application, point of sale, all those things that they need to operate, right? And how do you manage those systems remotely without to have to go there or connect there all the time? Well, with Azure Arc for Kubernetes, we are going to provide, again, a single pane of glass experience where you are going to identify those systems that need to, on which you need to take some action. You're going to be able to define policies, compliance settings that you're going to apply mechanically at very low operational cost. So Azure Arc for Kubernetes is going to be an area where you're going to get great benefits. Another area of Azure Arc where you're going to have a lot of benefits is if you need to run databases in multiple locations, in multiple form factors. Right? With Azure Arc enabled data services, you are going to benefit from the innovation that we put in Azure in infrastructure that are not part of the Azure ecosystem. It means that when you look at it, you may be looking at the cloud saying, hey, I cannot go to the cloud because I have requirements from policies or from regulation that prevents me from using public cloud. For example, you may have requirement by which the data that you manipulate must reside in your country or must reside on your own infrastructure because you're responsible for it. Well, in such situation, you may not be able to go use a public cloud. Well, with Azure Arc, we solve that problem because the public cloud is coming to you on your infrastructure. It means that if you have workloads for which you are able to use a cloud and in application for which you cannot use a cloud, well, for all of them, you can use the same technology because we are bringing Azure innovation on your premises, on your system, on your infrastructure with Azure Arc. So this is really the value of Arc, that you don't have to go to the cloud comes to you and you stay in control. In managed service, the value as well is that you don't have to take care about the infrastructure, the management. You just put your data, your application connect and work. That's it, right? And Microsoft takes care of all the updates, the security, all those things for you. With Azure Arc, since those workloads run on your infrastructure, you are more in charge of some of the configuration and some of the operation, right? So that's something that is really important for you to consider. So how do you get started with Azure Arc? Here I indicate to you 2 pointers that are really good point to start on Azure Arc. So I'll provide the slide deck later to you, so you may want to look at this documentation and this content. That is really a good starting point for you to consider Azure Arc. Now that we looked at Azure Arc, let's look at Azure Arc enabled data services. It is an aspect of Azure Arc. It brings all the data services of Azure into your infrastructure. Well, it will eventually. So Azure Arc data services relate to all those services in Azure that help you handle and manage data. It can be relational, can be something else. Everything that handles data is under the umbrella of data services. Azure Arc-enabled data services is this set of services that typically runs on Azure that we are enabling for you through Azure Arc. With Azure Arc-enabled data services, you can benefit from running always current softwares. You benefit from elastic scale, and you benefit from a unified management. That unified management that I mentioned earlier, this single pane of glass experience, no matter where your system is running, no matter if it's in the cloud, not even the Microsoft cloud, on some infrastructure outside of your data center, Azure Arc-enabled data services is going to enable you manage those systems at scale. Azure Arc data services comes in two forms, connected mode and semi-connected or disconnected mode, and I'll talk to you about that in a moment. So what are those specific data services that Azure Arc-enabled data services brings to you? Today, we are in preview of Azure Arc-enabled data services, and we offer 3 database engines under this umbrella. 2 of them relate to SQL Server, but today we are talking about Postgres Hyperscale on Arc, so we'll focus on that. So Postgres Hyperscale on Arc is the sibling of the PaaS service that we presented earlier. So Postgres Hyperscale on Arc, consider that it's not a new product in itself. It already exists in Azure. It's been in production for many years. We have thousands and tens of thousands of customers running mission-critical applications to it. So Azure Arc-enabled Postgres Hyperscale in itself is not a new database technology. It has been existing for many years. The innovation here is that we take that existing and proven technology and we make it available for you through a new vehicle. Instead of you coming to Azure PaaS and subscribing to the service, what we do is we package that service and we enable that on your infrastructure. Well, actually, you do enable that on your infrastructure, but you can get the service from us and run the same technology. So basically, if you are using Postgres Hyperscale on Azure PaaS, and you are using Postgres Hyperscale on Arc, it is the same database technology. So from an application standpoint, the migration should be zero cost. Why? Because it's the same technology, and it's based on the standard Postgres. It means that an application that is able to run against Azure Arc Postgres Hyperscale is able to run against Postgres Hyperscale in Azure. You just have to change the connection string, right? And that's about it. So really, it should be transparent for you. It also means that from a ramp up of your crews, developers, DBAs, then the cost should be very minimum because the technology is the same. Just the form factor differs. So this is really interesting for you in the enterprise. So this set of services are in public preview right now. We announced public preview a couple months ago at Ignite. And that's a free preview. So you should feel free to go ahead and move forward and try the preview and tell us what you think. I shared to you here the pointer to get you started. So feel free to have a look later and get started. You see, you don't need to have a specific environment to get started. We provide you some sample test environment that you can spin up in a few minutes and just use with the technology. Right? So really look into that. It's free, and you can already see the benefit of Azure Arc-enabled Postgres Hyperscale. So let's look at how Azure Data Services works anywhere. And here we get into some technical details, and I wanted to share a few things about the high-level architecture and the approach of the product. First and foremost, at the bottom of the screen here, and let me take another color, maybe it will be more visible. I take red. So run on any hardware. So whether you are using your bare metal systems, you are using VMs, you are using OEM hardware, you are running on Azure Stack, you're running on AWS or GCP, Google Cloud Platform, it doesn't matter. Azure Arc will run whenever you need it to run. On top of this hardware, we expect you to run Kubernetes. Kubernetes is this containerization technology, and we'll talk about it at the moment. And so the expectation and the requirement is that you have Kubernetes. Right? So we support a variety of flavors of Kubernetes today, already in preview, and we are building partnerships with a multitude of Kubernetes vendors and providers. So you should really feel empowered to go and use Kubernetes, any flavor that you need, to really benefit from Azure Arc. So from a customer standpoint, what you provide is these two boxes at the bottom of the display here. You provide the infrastructure. You provide the physical machines or the VMs or whatever you need, and you provide the Kubernetes cluster. On top of that, when you deploy Azure Arc data services, what you get is these things here. So what is it? First, you have the data controller. And second, you have the database engines. The data controller is the platform and the framework that provides the canonical capabilities of the database engine. It's a platform that supports the database engines and provides things like provisioning, update and patching, high availability, disaster recovery, all those things. Right? On top of that, you run the database engine. Today we speak about Azure Arc enabled Postgres Hyperscale, but you have other database engines that are already available and more to come in the future. It means that with Azure Arc data services, you can get on your premises or any premise, any database engine that is going to be available in Azure eventually. On top of the Azure Arc enabled data services, you have your applications. And what is super important here is that from an application standpoint, it doesn't matter what environment is hosting your Postgres database, right? It doesn't matter. Because as long as it's a standard Postgres that your database, your application is using, it will be able to use the Azure database for Postgres engines, right? So really from an application standpoint, you would just have to change the connection string to point your application either to one type of Postgres or to the other. Obviously, if you want to benefit from Postgres Hyperscale and the Hyperscale capability, we have seen earlier, that you need to partition the data, and the product helps you with that based on the distribution key. And as soon as you are able to do that, then you're going to be able to distribute the data and the queries. So really from an Azure Arc perspective, the three aspects are: you provide the infrastructure, that's the A here. You deploy Azure Arc data services, B, and you have your application that run on top of it as usual. So why Kubernetes? Kubernetes is a leading application container technology. And containerization of application, as you know, is something that is very much developing nowadays. It brings a lot of flexibility and resilience to any application deployment, and it brings consistency. You know that whenever you have a container that is packaged to deliver the right experience, you know you can duplicate that experience without being concerned that the deployment may have drifted from its optimum configuration. So that's one of the reasons that we are leading on with a containerization technology and with Kubernetes as it is the leading container technology. This type of technology provides the abstraction layer that allows Azure Arc to run on any physical infrastructure. This is where the magic operates, right? It isolates Azure Arc from the intricacies or the idiosyncrasies of the physical infrastructure that is hosting the Kubernetes cluster. So for a Azure Arc deployment, it doesn't know on what physical infrastructure it's deployed. It just that it knows is that it interfaces with Kubernetes. The Kubernetes layer is doing the interface with the hardware. But at this point, you do the operation. But from an Azure Arc perspective, it sits at a higher level. As I mentioned, Kubernetes provides a consistent and at-scale development experience within seconds. And what is super important as well is that with the GitHub's integration from GitHub, it allows you to do management at scale for your configurations. So Kubernetes works, as you know, by deploying YAML files that describe the resources, and you can change the configuration of those resources like that, or deploy them for that matter, based on the definition written in the YAML file. Well, if you club that with GitHub's, then whenever you create a repository, you put a YAML file in that repository, and you ensure that your Azure Arc is configured to look at the definition of that YAML file. Whenever you do a change in that YAML file on GitHub, and you prove a PR on that YAML file by which you change a configuration, the Arc agent notices that the YAML file has changed, pull that YAML file and apply this YAML file and answer new definition of the results across the board on all the resources that match the definition. So it means that at scale, you can do configuration management, policy changes, and all those things without having to connect manually to every single one of those machines or systems. As I mentioned, Azure Arc Data Services comes with two connectivity modes. One is a indirectly connected mode, and the other one is a directly connected mode. What we have in preview today is the semi-connected mode or indirectly connected mode. And what it brings is a lot of things, right? Already in preview today, you can do all those things. You can do, let me change the color of my pen again. You can provision and deprovision any database engine that we support today, be it a Postgres Hyperscale or SQL Managed Instance or SQL Server. It allows you to benefit from elastic scaling. We provide you with local monitoring capability, and we'll see that in a moment. You can do log analytics. You can do backup and restore, obviously. You can upload logs and metrics to Azure if you desire so. You can view your inventory that is deployed in your Arc deployment on premises or in other cloud. You can see all that from Azure. That's magic. No matter where these deployments are, in GCP, AWS, at the edge, in some data center, you can see all that from the Azure Portal. That's really magic. And it really enables you to manage those systems at scale, no matter where they are. And in these days, difficult days of COVID-19, being able to manage those systems, no matter where they are, is really an enabler for you. You can upload your billing information to Azure. You can benefit from different types of authentication. And as I mentioned, you have Azure DevOps with a GitHub integration that really allows you to manage the system at scale. The directly connected mode, we'll speak about that in a later session as the roadmap develops, and that will be available by the time the product goes into general availability. So let's look at a deeper dive of the architecture here. So as I mentioned earlier, you provide the infrastructure and you provide the Kubernetes cluster, which is this layer here, right? Like any form of Kubernetes, this Kubernetes cluster exposes Kubernetes APIs. And what is super important is this is those same APIs that Azure Arc Data Services is going to use to allow you to manage a system. So when you install Azure Arc Data Services, what you get is this box here, which, as we mentioned earlier, gives you the data controller and the database engine. Those components, database engine and data controller, interface with Kubernetes through the standard Kubernetes APIs, kubectl or kubectl or OC utilities that you use on Kubernetes. It means that we have a CLI that sits on top of it, but you are able to do commands directly from your data controller into kubectl, meaning that if you like so, you can use our generic AZ Data CLI to manage your system, but you can continue to use kubectl or OC to manage your Kubernetes, and you can use the same tools to manage Azure Arc Data Services. It is not a requirement to learn yet another API or another CLI. We have reduced the friction here by making sure that those things are integrated. So yes, you can operate Azure Arc and Azure Arc enable Postgres Hyperscale with the same native Kubernetes tools that you use today to operate your Kubernetes cluster. So that is super, super important. On top of that, so any tool that is able to interface with Kubernetes or with Azure is able to interface you with the system. So from a, let's say from a Postgres standpoint, the fact that the Postgres database is deployed in Azure Arc or in Azure doesn't matter, right? Because we run the community version of Postgres, it means that you don't need a specific driver. You don't need a proprietary driver or set of systems to connect or tools to connect to your Postgres instance. Any tool provided by Microsoft or not, provided that they are able to connect to a form of Postgres, is able to interface you with the system. And I'll show you that to you in the demo in a few minutes. So how does that work? Well, when you deploy a Azure Arc system, what you get is you download actually a container image from the Microsoft Container Registry, right? Eventually, you'll be able to create your own registry on your premises and deploy from there. But basically, you get the containers from us, and then that's the deployment. So when you do that, once the connected mode of Azure Arc will be available, then everything that you do on Azure in resources that are on Azure, you can do the same on any Arc deployment. Meaning that everything related to identity management, RBAC, policy management, deployment, you can manage that from Azure. From Azure down to your infrastructure. On the way up, which is, let me take a highlighter, that arrow here, you can upload to Azure your inventory information. You can upload logs and telemetry, all those things that will really light up the single pane of glass experience in Azure. By doing that, you are able to see what is happening on your systems, on premises or anywhere, and take action directly from there. So you may be wondering, hold on a second, you have Azure PaaS, managed service, you have Azure Arc. On Azure PaaS, as a customer, I don't have to do anything except I connect my application and I use them. On Arc, you tell me that I have to do the deployment, but it's Azure. How does that tie together? That's a good question. So to help figure things out, I prepared this chart here, which is going to summarize what are the roles and responsibility on Azure PaaS versus Azure Hybrid. And here we are going to ask ourselves a question. So who provides infrastructure? In Azure PaaS, Microsoft provides infrastructure. In Azure Arc, you as a customer provides infrastructure. Who provides the software? In any case, Microsoft provides the software to you. And on Arc, you are in control more about how you apply and deploy the softwares. Now, who does the operation? On Azure PaaS, Microsoft does the operation. On Azure Arc, you as a customer do the operation. Right? That is something that is super important. With Arc, you are in charge of the operation. Right? It's not like in Azure PaaS where Microsoft does the operation for you. No, with Arc, you are in charge of the operation. So from that standpoint, does Microsoft provide SLA on Arc? The answer is no. Microsoft provides SLA in Azure PaaS. Microsoft does not provide SLA on Azure Arc. So who's in charge of those SLAs? On PaaS, it's Microsoft. On Arc, it's you as a customer. So why is that? Why doesn't Microsoft provide SLA on Azure Arc? Well, the reason is because you do the operation and you own the infrastructure, and Microsoft has no control on that, right? So from that standpoint, we cannot provide SLA. What we do instead, we provide a set of technology that is capable of observing a range of SLAs, a range of capabilities like RPO, RTO, all those things. But because you own the infrastructure and you own the operation, then you are in charge. So how do you get started with Azure Arc enabled data services? Again, here to simplify, I put here a link to the documentation that really helps you go deeper compared to what I explained to you right now, and helps you get started. So where are we at right now in this presentation? Let's put things into perspective and look at it. We started with discussing about Postgres. We then looked at PostgreSQL Hyperscale in Azure PaaS service. Then I told you about what is Azure Arc. We expanded that conversation to look at what is Azure Arc for data services. So what's now? Well, now is for us to look at Azure Arc enabled Postgres Hyperscale. The simple answer and quick answer is you take Azure Postgres Hyperscale, you add Azure Arc enabled data services, and what you get? Azure Arc enabled Postgres Hyperscale. This is the moment where those two things that we talk together, Postgres Hyperscale, Azure Arc data services, come together to provide to you Azure Arc enabled Postgres Hyperscale. So in summary, what is it? It is one of the services that comes with Azure Arc enabled data services. It is this hybrid solution that runs Azure PostgreSQL on your premises, in public clouds, and at the edge. It runs standard Postgres, which is the open source Citus extension. Together, they transform your standard Postgres database engine into a distributed database system that can reach unprecedented levels of scales and performance by distributing the data and horizontally scaling out. So it is a great fit for multi-tenant applications and real-time analytics. How do you get started with that? I've provided here to you again a few pointers to really get you started very easily. My recommendation is you start here, right? And something that is very important as well, I think, is this other pointer here. Because when you put things into perspective, you're saying, well, but I don't have a Kubernetes cluster to play with right now. I'm not super familiar with Kubernetes, so it looks to me the ramp-up curve is kind of steep. Well, actually it is not. Because if you're not familiar with Kubernetes, we have you covered. If you don't have a Kubernetes cluster ready for you to go play with, we have you covered. How? You'd like to use Azure Arc accelerated experience deployment here, which is called as Azure Arc Jumpstart, which is a way for us to provide to you sample and test deployments that come with a pre-canned Kubernetes deployment on which you already have the binaries of the controller and the database engines, and you just have to deploy them within that containerized environment. And that runs on Azure. So it means that after this session, you can go there, press a button, and deploy. Right? So that's really an easy way to get started with Azure Arc enabled Postgres Hyperscale. Now, what's next? You'd like to see the product, right? So let's get into the demo. In this demo, I will give you a tour of Azure Arc enabled Postgres Hyperscale, and for this, I am assuming that most of you are either DBAs or developers. With that in mind, I will start by showing you different experiences or ways you can interact with the system, and then I will show you some capabilities like monitoring, log analytics, scaling out, and the single pane of glass experience with the Azure Portal. The environment I am using today for this demo is a 10-node Azure Kubernetes cluster. In that Kubernetes cluster, I have already deployed an Azure Arc data controller and a 4-node Postgres Hyperscale server group. First, I would like to show you the experience you have with native Kubernetes tools to interact with Azure Arc. So let's do that. I'm just taking a simple PowerShell window here, and I'm going to use a kubectl tool to interact with the system. If you prefer to use the OC utility, that's fine as well. So kubectl get nodes, so that I'm looking at the nodes that are supporting my Kubernetes cluster, and then you see here that we do have 10 nodes in the cluster. Now I'd like to show you the pods that are hosted in this cluster. So kubectl get pods -n arc to indicate my Azure Arc namespace. And here you see several pods that are running the system. In the documentation, I explain what those pods are used for, but I would like to show here to you is a pods dedicated to Postgres Hyperscale. Here I have 5 pods because I have deployed a 5-node cluster, 1 coordinator, and 4 worker nodes. Now let's look at the custom resource definition that we have created to manage Postgres Hyperscale. kubectl get crd. It will show you that we have 2 custom resource definition for Postgres right now. One is for Postgres version 11 and one for Postgres version 12. more recent version of Postgres will come later. We have that on the roadmap. So now let's use another kubectl command to list the server groups of version 12 that I have deployed on my cluster. So kubectl get pg12-n arc. pg12 is a nickname of the CRD for Postgres 12, and you can see that I do have one Postgres server group that is running on 5 pods, again, 1 coordinator, 4 workers, and it is in ready state. With that in mind, I'd like to show you another experience with the AZData command line, and here I'm going to use the command to list the server group as well. Azure Arc Postgres server list, and it will return the same instance and indicate that it is running on 4 worker nodes. So you have 2 ways to interact with the system, either the AZData, which is the standard way to use Azure resources, or with the AZ command line, or you can use the native Kubernetes tools like kubectl and OC. Now, I'd like to show you the configuration of this server group. So I'm going to use another AZData command here, AZData arc Postgres server show -n Postgres01, which is the name of my server group. And it will show to you the definition of that resource. It will share a bunch of information like its kind, the namespace on which it is deployed, and then you have the configuration of the engine, the extension that you may have been loading, the size of the cluster. Here it's running 4 worker nodes, and it indicates as well the configuration in terms of vCore and memory if you have defined requests or limits from a Kubernetes standpoint. In addition, it gives information about the storage for backups, logs, and data, and also it gives the endpoint that you can use to connect to the server group. As you can see, we provide endpoint for Kibana and Grafana. That is something that I mentioned to you earlier. By default, in standard, each Arc deployment comes with Grafana and Kibana for monitoring and log analytics. Locally on that deployment, you don't have to install anything. Yes, you have the possibility to upload that information back to the cloud if you want to benefit from a federated way of managing your deployment through a single pane of glass experience. You also have the Postgres endpoint that is exposed. That Postgres endpoint is going to be what you use to connect your application to the Postgres server group in Azure Arc. Now, from a Postgres user perspective, you may be using the PSQL tool to connect to your system. And you may be wondering if you can use PSQL to connect to Postgres Hyperscale on Arc. Yes, it is possible. Let's do that. So here I'm going to pull the PSQL command that I have formed already. And it's standard PSQL command where you give the connection string and boom, you're connected with PSQL to the Postgres Hyperscale server group in Arc. I can run a query from pg dist node. And that query is going to show me the shape of the cluster. So from PSQL, I connect to Postgres Hyperscale in Arc, and I do see the shape of the cluster. With that, I would like to switch to show you some experiences with UI tools. And I would like to start this section of the demo by showing you the experience of using a non-Microsoft UI tool to connect to Postgres on Arc. As a Postgres user, you may be familiar with pgadmin. And you can use pgadmin to connect to a Postgres instance hosted in Azure Arc. Here you see that I have referenced my Postgres 01 instance. If I expand it, I do see that I have some tables. I did preload some GitHub sample data here. If I right-click on it, I can easily view the data. So you can interact with Postgres with Microsoft and non-Microsoft tools so that whatever tooling you are using today, you don't have to change that experience. You can use what you use today. With that, I'd like to switch in and show you the Azure Portal. In the Azure Portal as well, you can see and manage your Arc resources. Here we see my Postgres 01 server group that is using 4 worker nodes, and you have all the detailed information about that server group and the standard experiences of Azure when you look at the portal. So it means that with Azure Arc, provided you upload and you upload the inventory information of what you have in your deployment, you can have a single pane of glass experience across your Arc deployment, no matter what is the physical infrastructure that is hosting those deployments. At this point, I would like to switch to Azure Data Studio. So Azure Data Studio is this developer and administration tool that Microsoft provides. And with that tool, you can also connect to your instances and manage the schema and the data. Here, I do see that I do have my GitHub events table as well, and I am able to run the query to retrieve the data. What Azure Data Studio allows you to do as well, if you look here to the lower corner of the screen, is you can manage your Arc deployment. Here you see we have one data controller with my Postgres 01 instance deployed. If I right click on that, I can choose to manage it, and that experience brings the similar view that you have from the portal, but this view is available from any client that you have on your system, and you get the same kind of information. One is from the portal, one is from a client tool if you prefer that. There you will be able to change the configuration, request assistance, and as we progress, we light up more experiences in this section, like we're going to have soon the configuration of the server parameters. What I mentioned as well with Grafana and Kibana, here from Azure Data Studio, you can invoke and connect directly to Grafana and Kibana. For example, if I click on that link, it takes me to Kibana, which is going to enable you to do some log mining to look at maybe some activity that has been happening on your system, right? So that's a very powerful experience that is available right at your fingertips from any Arc deployment from Azure Data Studio. Here as well, if you click on the link to Grafana, it brings you to the Grafana experience, and from there you can explore and look at what has been happening on your system. You can look at standard metrics or create your own metrics, and you can understand how the system has been behaving. Switching back to Azure Data Studio here, I would like to show you as well the integration of the Kubernetes native experience in Azure Data Studio. Here in the terminal section, you see that I can type any PowerShell command. So I can use the Kubernetes kubectl tool to interact with the system, and I'll get a command that I prepared earlier to look at the placement of the Postgres worker nodes on the Kubernetes nodes. So this is the standard kubectl get pod command, where I'm going to retrieve the node of the Kubernetes node that are hosting them. Here you see our 4 and 5 Postgres nodes. Let me zoom in, that are hosted on different Kubernetes nodes, which means that there is no resource contention. Every single Postgres worker node and coordinator is deployed on a different node of the cluster, which means that the server is performing at the maximum level of its capacity because there is no resource contention. Now I would like to show you the scale-out operation. For this part of the demo, I'm going to use 2 Jupyter notebooks in which I have the queries that I need. So let me open them up here. Open one, and I'm going to open a second one to the side. And first, let me show you how the data is distributed currently on 4 nodes. So for that, I run this query here. I'm going to connect to the server group. This table shows the number of rows per node. One of the nodes has 0 rows because it's a coordinator. Let me show you a histogram instead to visualize this data. Each bar of the histogram represents the number of rows per node. And as you can see, it is pretty well distributed across the node. Now, what I like to do is to scale out from 4 nodes to 8 nodes. So for that, I'm going to run an AZData command from the terminal to the left. So AZData Arc Postgres server edit to indicate I want to change the configuration. -w8. -w is a parameter that indicates the number of nodes we want to scale out to, and I indicate the name of the instance I want to scale. So Postgres 01. Right. I run this command, and now the system has started scaling out for 4 nodes to 8 nodes, and we can see that to the terminal to the right by using a kubectl get pods-n arc. And here you can see that I have 4 more nodes that are being added, and they are in container creating state. Now the scale out operation is complete, and we can verify that by running the kubectl get nodes command here, and you can see that pods 5, 6, 7, and 8 are in running state. So now we need to redistribute the data. Right now the data is distributed across 4 nodes. We need to distribute the data across the 8 nodes. So to do that, I'm going to run a command to redistribute the data. This is this select query here to the left. And while the redistribution of the data is happening, your application continues to run. So really the scale out operation and the redistribution of data is an online operation. So 0 downtime for your application. That is super, super important for mission critical applications. So now what I'd like to see, to show you here to the right, is a distribution of data as now that we have 8 nodes. So I run this query here, and as you can see, the data is being redistributed. I can visualize the histogram here, and as you can see to the right, we now have 8 bars in the histogram because we have 8 nodes compared to the left where we had 4 bars in the histogram before we scale out. So to the right, you see that the bars are the same level as well as the distribution of data as completed. In this demo, I showed you the different experiences and tools you can use as a DBA or a developer when using Azure Arc enabled Postgres Hyperscale. I showed you the monitoring and log analytics capabilities. I also showed you how easy it is to scale out, and we've seen that the scale out operation is an online operation, meaning that it creates 0 downtime for your application. Now, if you'd like to go deeper and investigate more about Azure Arc enabled Postgres Hyperscale, I would recommend you watch 2 additional demo videos. One in the Azure, in the keynote that Rohan Kumar delivered in this event, where you can see how you can use GitOps to automate a deployment at scale within Kubernetes for your Azure Arc enabled Postgres Hyperscale. And second, if you are interested in the pure performance aspects of Postgres Hyperscale in Azure, please watch the demo video I point you to at the end of the slide deck. Speaking of slide deck, let's go back to it. There is one more thing I need to talk to you about. I'll see you there. With Azure, you have the choice of using the deployment of Postgres that you need, either a single node as a managed service, or you also have the Hyperscale form factor either as a managed service or as an hybrid solution on any infrastructure. The other point is that Postgres Microsoft is truly open source and is about the community. There are multiple Postgres committers working at Microsoft, and a lot of their time, energy, and expertise is dedicated to grow and help the community, right? So really, as I mentioned, this Postgres community is vibrant and very active, and Microsoft is actively contributing to it. And you can benefit from it by using one of those technologies in Azure, either as a managed service or on your premises with Azure Arc enabled Postgres Hyperscale. So today, what we've done is we looked at Postgres Hyperscale on Azure Arc. I started by explaining to you some of how you can benefit from Postgres. We look at the technology known as Postgres Hyperscale that brings unprecedented level of scales and performance to your system by horizontally scaling out and distributing the data and the queries. We look at Azure Arc and one aspect of Azure Arc, which is Azure Arc for data services. And then we see how the two come together to offer you unprecedented level of scales on your premises with Azure Arc enabled Postgres Hyperscale. With that, I'd like to thank you for your time, And we have now a few minutes to go in the Q&A session. Thanks, folks, for joining today. Thanks to all the partners for this great event, and looking forward to have your feedback on Azure Arc enable Postgres Hyperscale. Thank you. Bye-bye.